Welcome to the OMS CS6340 Software Analysis Lesson 0 Course Introduction for Summer 2026. I'm Chris Pock, and I'll be one of your instructors this semester. We're going to go over some details of how this course will run over the next few minutes. In this video, you will learn who we are as an instructional team, what you will learn as students, the different parts of the course, what we expect of you, and what you can expect from us. In a moment, you'll hear from the people themselves, but you can see that we have a very experienced team teaching this course, and many of us have been working together for many semesters. That's the number after each person's name. We try to play different people's strengths and interests, so some people will be more visible to you at certain points of the course than others. It's also a part-time and a second job for every single one of us here, so please be patient with us, especially during U.S. business hours. And now you'll hear from the people themselves.
Hi, I'm Mayur Naik, and I welcome you all to 6340, a course I created back in 2015 and continue to be involved with to this day. The course is enriched every semester by a wonderful and dedicated course staff based on feedback from past students. I'll be a co-instructor and look forward to interacting with you throughout this semester. I hope you find this course useful and have fun along the way. Welcome.
I'm Chris Pock. I'm a 2017 OMSCS graduate who took the initial OMSCS offering of this course all the way back in 2016. I've had the privilege of being one of the instructors since 2018. By day, I work for a S&P 500 financial institution where I lead software development for a product used for making corporate accounts payable transactions via virtual credit card. I look forward to having you in class this semester.
Hi everyone, I'm Kelly and I'm one of your head TAs this semester for software analysis. By day, I'm a senior application developer in the life insurance division at Pacific Life. I graduated from OMSCS in the summer of 2017. Prior to graduating, I was a TA for computer networks for 3 semesters, but software analysis was the last class I took in the program, and it was definitely my favorite. So after graduating, I switched over to TAing for this class instead. I'm excited to share the material with you all this semester, and I look forward to seeing you around Piazza and hopefully in our office hours on Slack. I think we have a great instructor and TA team, so I hope that you all will enjoy the class as much as I did.
Hello everybody, my name is Joel, and I will be one of your head TAs for the software analysis course this semester. I graduated from the OMSCS program in summer of 2017, and this was one of the last courses I took before graduating. I learned quite a bit. I figured, well, the best way to learn something better would be to teach it, so I started TAing this course shortly after I graduated, and I've been doing it ever since. In my day job, I'm a senior application developer for a manufacturing company in West Michigan. And then outside of work, I've got a wife and 4 kids that I spend quite a bit of time with. We like to play a lot of games. Board games, yard games, computer games, games. I'm looking forward to this semester and interacting with you all through Slack and Piazza and whatever else we can figure out, and hope it'll be as fruitful for you as it was for me.
Hi everyone, I'm Susie Lynn, and I will be one of your TAs this semester. I first took this course back in 2018, and I really enjoyed it. We have a great TA team, and I hope you will learn a lot about software analysis. I look forward to working with you this semester. Wishing you the best, and see you guys around.
Hey everyone, my name is Joe Doherty, and this is my 6th semester as a TA for software analysis. I graduated in fall 2019 and work as a sales engineer at a tech startup, but when I'm not selling software, I like to get my hands dirty in the garden or working on my cars. This is one of my favorite courses in the program, and I'm glad to be back for another semester. Looking forward to working with you all. Thanks.
Hi all, my name is Samantha Llewellyn. I'm a returning TA for this course. I took the course back in 2018, and I really enjoyed the class structure and material, so I was excited to jump in and TA the course starting in 2019. I really enjoy helping others learn, especially with the amazing group of TAs that we have for this course. So I am looking forward to meeting you all and hope you have a really great semester.
Hey everyone, I'm John Daniel. I'll be one of your TAs this semester. I'm a current student in the program, but software analysis was one of the first courses I took, and I really enjoyed it, so I decided to try to become a TA for it. I think you'll enjoy the class too. We cover some cool concepts that aren't covered in other courses. And when I took the course, it gave me a greater appreciation for the various analyses we can perform to improve our code. So hopefully you'll find a similar appreciation. Anyways, we have a great team, and we work hard to make this course one of the best in the program. So good luck, and I'll see you around on Piazza and Slack.
Hi guys, I'm Joseph Kanak. I'm one of your returning TAs this semester, and like all of you, I'm a student in the program. I've enjoyed the course topic since before I took this course. I really appreciate the theory behind it and the applications I learned in the class, and I hope you do too. I also work full-time on a fraud detection team, and when I'm not working or schooling, I spend my free time out and about with my wife and kids. I'm looking forward to working with you all during the semester.
Hi, my name is Kevin Winbigler, and I am currently a student in the OMSCS program at Georgia Tech. I recently completed the software analysis course, and I loved it. I thought the material was exciting, challenging, and applicable to my day job as a DevOps engineer for a medical device company. Outside of work and school, I enjoy photography, camping and hiking, and reading and watching movies. I look forward to working with each of you this semester on our journey to understanding software analysis. Thank you very much.
Hello, welcome to CS6340 Software Analysis. My name is Jared. I am one of your TAs this semester. I took this course a few semesters ago and really enjoyed it, and I hope that you enjoy it as well, and I look forward to working with you.
Hi everyone, I'm Alex. I'm a second-year student in the middle of my OMCS journey. Professionally, I'm a software engineer at Meta, focusing on the mobile development. Starting this year, I have been working on AI glasses experience. This is my very first semester as a TA for the software analysis course. I took this class 2 semesters ago, and I really enjoyed it. I liked the materials, how class was organized, and its focus on practice and real-life challenges. Hope you will enjoy it as well.
This course is about a body of powerful yet practical techniques and tools to improve software quality, and thereby cater to the most pressing need of modern software development. To that end, the course focuses on algorithms that analyze code. We will primarily focus on software quality in terms of correctness, security, and performance, although the methods covered are applicable to other aspects such as code readability and maintainability. Let's face it, writing correct software is hard, and in today's world, software errors have an enormous cost. One study from 2016 estimated that software errors cost the United States economy a whopping $1.1 trillion. Some of the notable examples of how software errors cost us all include failures of expensive systems, such as NASA's Mars Polar Lander, which crash-landed on Mars in 1999, and the infamous power grid failure and ensuing blackout of the northeastern United States in 2003. Security vulnerabilities that allow malicious users to steal information from or hijack everything from IoT devices to system software to web applications, and setbacks to emerging technologies such as autonomous vehicles. What problems do our techniques explore? How can we automatically test code effectively without having to write test cases? We'll cover that in our automated test generation lesson. How does your IDE know when a variable is unused? We'll cover that in the data flow lesson. How does a compiler allocate registers efficiently? Also data flow. How can we find infrequent bugs in huge systems? That's the cooperative bug isolation lesson. How can you find a small test case for bugs that are not well defined? We'll cover that in Delta debugging. And how does a strongly typed language prevent bugs? We'll cover that in type systems. What is this course not about? This course will not teach you how to write code, although it will make you a better programmer. You are expected to be fluent in a C family language. We will primarily be using C++ this semester. This course is also not about how to use prevalent testing frameworks in industry such as Selenium. While the course will include case studies that discuss such tools, however, the primary focus is on the concepts and algorithms underlying such tools. This will enable you to discern the strengths and limitations of a given tool under a set of real-world constraints, be able to adapt an existing tool to a new language or application, or even develop such a tool entirely by yourself. If you were expecting to learn how to write a test plan, how to automate testing, or other tasks that would typically fall under the QA team in a software development organization, that is not what we will be covering in this class. Those topics can be important, but I would argue the topics we cover are less well known and equally important to writing quality code in a rapidly changing environment that is rapidly leaning towards analysis to improve code quality and reduce bugs. Why test software when you can make software to test software? This is a quote from a past student that I think very accurately sums up what we do in this course. This course is a survey course. Now, what we mean by that is that every lesson is a different topic. We have labs that support many of these lessons. And one way I like to think about it is like a general chemistry class. So there's a good chance you took general chemistry as an undergrad, and how it probably worked is you went to a lecture on Monday and Wednesday, and then you went to a lab on Friday. So on Monday and Wednesday, you're learning about acids and bases from the stage, and then on Friday, you go into the lab and you mix some test tubes together and you see what happens when you combine different acids and bases. And then next week, you'll be on to a different topic like the ideal gas law. So much in the same way, we are going to cover a bunch of different topics in this course, and you're not going to become an expert in any of them, but our point here is not to turn you into an expert in a little area of software analysis, but to give you an idea of what is out there in this fascinating field. There are different parts of this course, so we have lessons, labs, quizzes, ed, our discussion forum, office hours, which are by Slack, and an exam. I'll talk about each of these sections a little bit, although I've already hinted at a couple of these. So first, lessons. We have 11 lessons. Well, we really have 13 if you count this as lesson 0 and lesson 1.5, which for the purposes of testing, we will consider as part of lesson 1. These lessons are available to you on Ed, where I suspect you're watching this right now. They're also available on YouTube, although I highly recommend watching them on Ed because there are some embedded quizzes in the videos outside of this introductory lesson, and you're not going to be able to access those and get real-time feedback if you're watching on YouTube. These in-quiz videos are not graded. They're just there for your own practice. And to that end, they were actually built for a previous platform that we used. And unfortunately, the current platform is a little less flexible when it comes to these quizzes. So if you have an answer that you believe is correct and you watch the answer explanation and it shows the same answer that you got, but it graded it incorrectly, you probably have an extra space or a missing space or the wrong type of bracket or something like that. And don't panic because we're not counting any of these grades from here. It's just for your own learning to help you understand if you know the material. I should also note that on Ed, below each video, there's a space where we will put any links that appear in that video or any notes of errors that may appear in that video, because unfortunately, some of the videos do have a couple of little glitches in them that we've been unable to get fixed because no one seems to have the original files from the original videos that were created for this course back 6+ years ago. Labs. So what is the point of having labs in this class? Well, the labs are designed to back up the lessons. You're going to have 7 real labs plus an intro lab that's worth half as much as the main labs. For the main labs, you're going to have access to an introduction video, and before you complete a lab or even start on the lab, you should watch the corresponding lesson and the intro video. The intro videos were based on many semesters of feedback from students and answer the most common questions, and for some of the labs that have a little bit more challenging of a setup, may even walk you through parts of the setup. So you're going to be starting from behind. You might say, oh, I don't want to spend time watching another video, but you will probably complete the labs in half the time if you watch the video content first. In terms of complexity for your planning, we have 2 labs that I would consider in the easiest group, the introductory lab, which is half-sized, and the type systems lab. Then we have a couple labs that are in the middle, Datalog, Delta, and Clay. And then we have 3 labs that we'd consider to be the hardest: fuzzing, data flow, and cooperative bug isolation. Most students in their end of course surveys list either Lab 1 or Lab 5 as the lab they found the most difficult in the course. And here's a big hint for you. Both of them have some very similar concepts, so if you are not starting from your Lab 1 code when you're working on Lab 5, you are coming from behind. With our labs, we will provide some test cases, and there will also be some hidden test cases. And you're going to be submitting your labs through Gradescope, and Gradescope is our grading standard. Now, what that means is if there's any dispute of does this work or does it not work, we have to see it run on Gradescope. We can't see like a video of it running on your computer and consider that. But you have access to the Gradescope environment, so we can be very confident that there's not going to be any kind of environmental related surprises. Most of the labs in this class use the LLVM framework. LLVM has its own portable assembly language, and this framework makes it very easy for us to develop different kinds of analyses. In particular, you'll see labs 0 through 3, 5, and 7 are on Gradescope, although for labs 3 and 7, not Gradescope, are on LLVM. On labs 3 and 7, our use of LLVM is a little more abstracted away from you, but it is still there. So what is LLVM? It is a compiler infrastructure project. Now, what that means is it's not just a compiler, but it's the whole ecosystem built around a compiler. So in this case, it's the Clang compiler, and Clang or its derivatives are used for Apple. It's the default compiler for Mac OS and iOS. Sony uses it for their PlayStation. NVIDIA uses it for their integrated graphic chips, and AMD and ARM also use it. So why did we pick it? Well, first of all, it's a mature tool chain. It has many existing tools that are helpful for the kinds of things we do in this class. For example, it has the Z3 analysis engine that we will use for data log in Lab 3. It also has Clay, which is a dynamic symbolic solver that we will use in Lab 7, also called Clay. LLVM is designed to be very flexible. The idea is that you can insert your own analysis into the compilation process. So we don't have to worry about running tools and interfering with compilation. The compiler itself just lets us slide different things we want in. Some students over the semesters have asked if we could make a lesson on LLVM to help them get started because it is such a big part of our course, and it's an open source project which has many of the limitations that are frequent with open source projects, such as documentation that has some limitations, and it's an evolving project, and we're not always on the most current version. So you say, okay, well, that seems like a reasonable request, and I'd agree. But no one in the course staff is an expert in the way that people who live and breathe LLVM all day are. And so what we have chosen to do instead is to recommend a couple of different resources. So here are 3 videos, and of course you can click below the video on Ed to have hyperlinks here that will give you overviews of LLVM. Now, all 3 of these are somewhat duplicative, and I would encourage you towards the 2 longer ones in this case as a good introduction, and it will walk you through some of the basics so you can feel like you're ready to hit the ground with the first lab. In terms of how we test labs, one of the ways that we do it is, I want to give you an example of how we do public and private test cases. So in this case, we are testing this function main. Main is our test harmonious and square is the function under test. Now you can see that this is buggy code. The function square takes in an integer, returns an integer, but instead of squaring the number, it's multiplying the number you passed in by 2. So this is buggy code, and this is something that we frequently do in this class, give you buggy code and give you a tool to figure out how to fix the code. Okay, so if we just run this, we'll get an output of 0 and 2 from the test cases we put in main. Now, so we ran it with the value of 0 and it outputted 0. We ran it with the value of 1 and it outputted 2. Ooh, that's not correct. The value of 1 squared is 1, not 2. Okay, so what happens if we just change it to 1 instead of 2 that we're multiplying n by? Now our test cases pass. Okay, but you should be screaming at your screen right now. This is still not a correct program. And one of the things that we have frequently seen students do is submit code that solves the test cases but doesn't actually solve the problem, just like what you're seeing here. So in this case, we'd provide you 0 and 1 as the test case, and in fact, we encourage you to write your own test cases and share them with your classmates. Although the course staff will not comment on the correctness of student-provided test cases, we highly support you creating them and discussing the results with each other until you're confident you know the answers. Now, here's what we would probably actually run for grading. You'll see instead of just 0 and 1, we also pass in 2 and 3. So if you stuck with this buggy implementation where you're returning 1 times n, you're going to get 0, 1, 2, and 3 as your output, which is, of course, wrong. But if you instead had a correct implementation, like here we have n times n, you would get correct output and full credit. So the one that passed the test cases but was not actually correct would get you half credit, assuming we weighted all of them equal, and the one that actually solved the problem would get you full credit. You'll be able to see the weight of all the test cases up front, and for most of the labs, we'll let you know your score for about half of the grade prior to releasing grades. Some it's higher, some it's lower, but it's usually around half. Quizzes. We give you a quiz that goes with each of the lessons, keeping in mind that lesson 1.5 is really a continuation to lesson 1. So I'd recommend watching lesson 1.5 before completing quiz 1, but there is no graded quiz 1.5. So to that end, 11 quizzes. They're designed to be done after watching the lesson. Some students prefer doing it after the lab for labs where there's a corresponding lab that goes with the lesson as well. But there is no requirement to do that. In terms of the format, each of these quizzes has a 30-minute time limit. They're open book, open note, open internet searching, but they're closed posting, they're closed discussing, and closed sharing. Now, I'll explain in a minute why we do it that way. We have soft deadlines on these quizzes, so I've set a deadline for each of these to be due the week after it's assigned. Now, I've done that because Canvas will prompt you with what is coming up in terms of graded work, and I want you to be aware that, hey, you should be doing these quizzes, but we don't actually enforce that deadline. The firm deadline is the last Monday of class. And this is why we have to limit the discussion and the sharing, is because you could have people all the way up until the last Monday of class taking the first quiz. One other note is quiz 1 has 2 attempts, so you can take it twice. Now you're going to get a different quiz each time you take it, and it will keep your highest score. But this is a thing that we've only done for the first quiz, and we've done it because we know going into the first one, you don't know exactly what to expect. But quizzes 2 through 11, you're going to get just 1 attempt on, so make sure you're ready before you take it. Our discussion forum is Ed this semester. One of the things that we've learned over many semesters is that the best learning happens student to student. So to that end, help us help you. Before you post on Ed, please search so you can avoid duplicate posts. Now, why do we say this? Well, first of all, it keeps the forum more organized, and if the question you're asking has already been answered, you have an answer right away if you search for it and find it. You don't have to wait for someone else to answer it. There's a heart button under or next to the post, next to the title of each post, and if you heart posts that you find are helpful, it helps us and it helps your classmates see you posts that are specifically helpful. And we give additional extra credit bonus for particularly helpful posts. We'll talk more about that later. Please be civil on the forum. We expect you to be nice to other students, and written communication is often easier to misinterpret what people intended than face-to-face communication or even a live communication of any kind. So please try and assume the best of your classmates and be nice to each other. We expect you to check Ed daily, and there are going to be some pinned posts at the top of the list of posts, and any post that is pinned is required reading. You are responsible for the content of anything in a pinned post. Now, to that end, posts will be pinned for at least 24 hours, so if you're checking in at least once a day, you can be sure that you will see everything. Everything will be pinned for at least a day, so you're not going to miss pinned posts. And I hinted at this, but Ed posting is the foundation for our class participation bonus. So here is what the Ed forum looks like, and you'll see over on the left-hand side, you can see a list of the different categories. In the middle, you have the list of posts, and over on the right, you can see the details of a post. Now, in this case, since it's the start of the semester, you'll see that there's 5 posts that are pinned, and then there's one other post, Introduce Yourself, that's not pinned below that. Now, the ones up at the top that are pinned are required reading. The Introduce Yourself post is optional reading. And so we encourage you to post different questions that you have and interact with your classmates and learn from each other, but it is not required that you read every single post. Office hours. We hold office hours using the Slack chat application. This is an opportunity to get one-on-one help from a TA or instructor. Some classes use office hours as additional lectures. That is not the case in this class. There are some general questions that are asked, and we encourage students to ask those publicly so that other students can look at the chat history and benefit from it. But most of the questions we get, most semesters it's between 3/4 and 90%, are questions that are private in nature. And so this is, can you help me debug my code? I have a question about this graded work. Questions of that nature where we can't answer them publicly. This is not an additional content. There's no video recording that we expect you to watch. They happen in the office hours channel on Slack. Whoever is hosting, usually a TA, will announce the start and the end of office hours, and anytime that we have started them and not ended them, you are free to ask your question in that channel. And if you have a private question, you can ask for the host to follow up with you. Now, what should be private? I talked about this a little bit, but anytime you are sharing your code, please make it private. Or if you're discussing a lab answer, even if it's not code, I believe the pattern is X. Please don't post that publicly. And anything related to your grade, Georgia Tech's interpretation of federal student privacy law actually does not allow us to talk about your grades publicly, even with your permission. So if you say something like, I got a 90% on this assignment, I can't in any way, if you say that in a public forum, I can't in any way say if that's correct or incorrect. You're going to see the first office hours this week, and there is a calendar pinned on the Slack channel, and it's also available from the sidebar in Canvas that will show when office hours are happening. We do not keep the office hours on the Canvas calendar. They're on their own Google Calendar, which you're welcome to add to whatever calendar application you use. It's available publicly, but we don't put them on the Canvas calendar because we wanted to limit the Canvas calendar to things to be deadlines and due dates, because otherwise, with the number of office hours we have most semesters, it's easy for you to miss required stuff in the office hours noise. So what goes on in an office hour? So in the public office hours channel, a student posts, I have a Lab 7 question. Then they post, I am currently testing my algo and I have a quick question. The scanner class consumes newline characters. Do we need to reinsert those? Now, I would respond in a thread if I'm the one hosting the office hours, and I'd say, if your algorithm is fine without them being in your working data, that's fine as long as you know what line is what. And the student responds with, sweet, thanks, and I respond with, glad I could help. So these are the kinds of, this is a public question, but you could see how it would be a similar kind of discussion. I'm having a problem. I'm not sure why this declaration isn't working the way I thought it would. I was expecting it to do X and it's doing Y, and then include a code snippet. That would be a great thing to share, but please request a direct message if you want to have that kind of conversation. So here's an example of a private question. So starting in the public office hours channel, DM please, I have a Lab 7 question. Then we switch to direct message, and note that the staff needs to initiate these messages. In a class that frequently has hundreds of students, it's just not feasible for us to accept students sending us direct messages. When we've allowed it before, we've had you messaging us literally 24 hours a day. Like, I don't think some of you sleep, and it just wasn't sustainable. It was burning out our staff. So we need to initiate them even during office hours. And some of the more busy hours, we will have more than one person working on answering office hours questions. So if Kelly and I are hosting office hours together, and Kelly's the one who has availability, but you send me a direct message, I'm not going to answer it. So just keep it on the main channel, and we'll follow up with you to start the direct message chain. So I follow up with the student. Hi, student, how can I help you? And the student says, I added a clay assume in the main function, but I am still struggling with meeting the required runtime. I think the pattern is any input containing A, but when I try and constrain to that pattern, I am getting a seg fault. And then I ask the student, can you share your full file so I can take a deeper look at your code? And the student shares a file. And so you can see how this kind of conversation would go back and forth. Let's talk about the exam. This is probably most people's least favorite feature of the course, and rest assured, the course staff doesn't particularly like exams either, but for a couple of reasons, we've settled on, for now, this being the best format to have some labs and also an exam. You're only going to have one exam in this course, and it is going to be available for 10 business days, from Friday at 8 a.m. Eastern Time until Monday, 10 days later at 8 a.m. Eastern Time. You can check the course calendar for the exact dates. Now, the exam that we give you is not comprehensive. What I mean by that is everything that is on the exam, or everything we teach you in this course, is covered by either a lab or an exam, but not both. So for example, there are the Introduction to Software Analysis section, which includes soundness and completeness, lesson 1.5, does not have a lab that goes with it. So we are going to give you exam questions on that. The Introduction to Software Testing also doesn't really have a lab. I guess you could argue Lab 0 kind of covers these, but it's lower weight. So we include those two lessons, 1, 1.5, and 2. Also, lessons 4, automated test generation, and 6, pointer analysis, do not have labs currently that go along with them, so they will be on the exam. But all of the other lessons have labs that go with them, so we will not be including them on the exam. And since I've already said we have 11 lessons, but pointer analysis is lesson 6, we're going to give you the exam right after the pointer analysis lesson instead of waiting until the end of the course. This ends up usually working out much better for everyone because the end of the semester tends to be a busy time for most people. And while the exam is available for a fairly long window, it does still mean you have to do it within those specific 10 days. At the end of the course, we have no such deadline. You can submit everything that's due at the end, with the exception of the end of course survey, which you'll have 3 weeks to complete. But all of the labs, all of the graded quizzes, you can submit those way early. So if you want to get a jump start on your break and finish a couple weeks early, that's something that you can definitely do. And you wouldn't be able to do that if we gave you the final at the end. So while sometimes people are saying at midterm time, maybe we should do this later, come finals time, you'll be thanking us that the exam is done. You have 3 hours to take the exam within that 10-day window. and the covered lessons are fairly evenly represented. We'll give you a post with more exam details a couple weeks before it opens, and it will give you the exact details of how the coverage works. But the intent is that things get equal grade value, whether it's covered by a lab or an exam. So on our exam, we're going to give it to you via Canvas and HonorLock. So HonorLock is the proctoring system. Canvas is how we'll display the questions. Some types that you might see include multiple choice, fill in the blanks, free response, drop-down questions, etc. It's open course notes plus 1 page of your own notes. Physical paper is limited to scratch paper that you show us is blank at the start of the exam. And the exam will be invalidated, meaning you get a 0 if you do not follow the exam procedures. So please make sure that you pay special attention to them, and we'll be posting them, and there'll actually be a quiz that you need to take. Not a quiz in terms of you have to study for it, but you have to read all of the exam procedures and acknowledge each section before the exam will unlock for you. So we're all on the same page before you take the exam. Again, we want to save you as much grief as possible. We don't want there to be any surprises. So in terms of the exam procedures that trip people up, there's a room scan, and the room scan absolutely must show your workspace and your computer. There is a way you can do it without a mirror, but you have to have either an external webcam or a mirror. If you are using a laptop with a built-in webcam or a monitor with a built-in webcam, you absolutely have to have a mirror. So you'll either need to find a mirror or find an external webcam, and a bigger mirror is better. Pulling a mirror that's hanging on your wall off and using that, if it's easy to get access to, can be a very good way of showing it. Using a little pocket makeup mirror usually produces inadequate room scans. So get a mirror now if you don't have one, or a USB webcam. You also must be alone while taking the exam. So I know that sometimes in our world where people work remotely and people are home at weird times compared to what happened a couple years ago, I know sometimes this can take some planning. So that's why we give you the dates right at the start of the semester, and we tell you that you're going to need to be alone. So if you need to figure out how you're going to get a couple of hours by yourself, you have some time to figure that out. Now, why do we follow all of these exam procedures? The reason is we have had some past issues on exams with cheating, and having these proctored exams lets us verify that it is you completing your coursework. And at the end of the day, I'm an OMSCS grad as well, and I want my degree to continue to be worth something, and I think you want your degree to be worth something as well. And if people can just cheat their way through the program easily, our degrees will not be worth something in a couple of years. And so we have to follow some procedures to make sure that you are doing your own work. So in terms of what we expect for these room scans, we absolutely have to see your workspace, what is in front of you, what you're looking at, and we need to see your entire computer, your keyboard, monitor, mouse, or laptop equivalent, and the entire display, and to be able to see that any other displays that are on your desk, things you'd easily be looking at, that they're either unplugged, preferably they're turned around or covered with a towel so it's clear that you're not using them. We have some sample room scans on YouTube that you can see, both good ones and bad ones, so you can have high confidence that you're going to do a room scan. That's going to be great and get us everything we need. Let's talk about the course grading. Our goal is fast turnaround. There's a lot of research that says you will actually learn more if you get feedback faster to when you do your work. So things like our graded lesson quizzes will give you instant feedback, but we like to have even the labs and the exams turned around pretty quickly so you can know how you're doing on them. We will promise to return all grades within 2 weeks. The syllabus quiz is worth 2% of your grade. You'll have 3 surveys that are worth half a point. all 4 of those, the 3 surveys and the syllabus quiz, are all or nothing grades. In fact, the syllabus quiz, you'll have to get 100% to unlock the rest of the course. And again, that is just to make sure that we are on the same page at the start of the semester. It's easier to make sure we have common assumptions, common understandings, than to deal with the fallout if we disagree about what we were expecting of you. Your labs will be 60% of the grade, 8% each, except for the intro lab, which is half-sized at 4%. And your quizzes will be 16.5% or 1.5% each. That's the 11 graded lesson quizzes. And the exam will be 20% of your grade. The way that works out is it will be 8% on the labs that, covering the lessons that have no lab with them. And then the remaining 4% covers the lessons covered by the intro lab. We also have a class participation extra credit bonus where you can get up to an extra 5% added to the top of your grade. Now, in terms of the individual items you'll see in the grade book, we don't curve those. Any adjustments we need to do to grades, we do on the grade brackets for the final exam that we release at the end of the course. We will release them after the midterm exam, and then I will release them again along with the last graded work, which will be your 7th lab at the end of the semester. So that's where you'll be able to see it's typically greater than 90% is a A, greater than 80% is a B, greater than 70% is a C. But if there's any variation to those, I will announce where I expect them to be at the midterm, and they will be no higher than what I announce at the midterm. And then I possibly may adjust them at the final end of the course. But based on what we have done in similar classes, don't expect the brackets to change. If they change, it will probably be very small amounts, but the last couple of semesters have all been 90, 80, 70 as the lines. We do our comparison against how the class performance is on specific assignments relative to past classes, because my goal is that you get the same letter grade in whatever semester you take the class for the same amount of effort. So you shouldn't be penalized if you happen to be with a group of really, really sharp students. And on the other hand, you shouldn't get an extra undeserved boost if you happen to be with a group of students who are below average compared to past classes. So what are our expectations for you? We expect you to be prepared to keep up with your work. This is a class where you can very easily work ahead. We have several assignments already available to you on the first day of class, and we will release all of the graded work on the second Monday of class. So that's exactly 1 week after class starts. So this is a very good opportunity for you to be able to work ahead. We expect you to do your own work, and we'll talk more about what that means in a minute. We expect you to ask good questions, and I already covered some of what makes a good question when we talked about office hours. But basically, come and don't come to us with something like, it doesn't work. Tell us what you've tried. Tell us any ideas you have about why it's not working, etc. And we expect you to participate in class. It's not strictly required, but you'll get more out of class, and you have an opportunity to earn some extra credit if you are helpful in the class, and it makes it a better experience for everyone. How can you make sure that you're ready for the class? We have a readiness assessment, which you can use to see if you are prepared for the kinds of things that we'll be doing in class. Now, this readiness assessment isn't a line by line of what you're going to need to complete each lab, but it gives you some of the basic concepts that some students in the past have struggled on that are things we expect you to know coming into class. We expect you to be able to read documentation and figure things out. For example, I already mentioned LLVM is a large open source project. It has probably over 1 million lines of code, and it has some very well done documentation, but it also has other places where the documentation leaves things to be desired. but this is fairly standard in the world of CS, and so we expect you to be able to figure out how to handle those kinds of situations. You're going to be using C++ in most of the labs in this class, and for Lab 2, you're going to need to be able to use pointers. We mention this not to have you panic if you haven't seen a pointer in a while, but we know that since many people do not use pointers on a regular basis these days, even if you have a solid CS background, we just give you a heads up that this is something that you will see in one of the labs in this class. Late work. Everybody's favorite topic, right? We do not hold up class for you. Now, what that means is that we require verification from either one of the instructors or the dean of students for any absence to be excused, meaning that we will accept your late work. The kinds of things we accept are typically sickness, deaths in the family, military deployment, and natural disasters. If you live in the path of a hurricane, be safe first. We want you to get out, but if you can, bring along your computer or whatever materials it takes for you to keep up with class, just in case it's a while before you're back home, so you're not stuck somewhere with a lot of free time on your hand and unable to work on class. Now, what we're not able to accept for extensions are vacation, business travel, and weddings, including your own. Because of this, we release our labs early. We have 2 of them that are available right from the start of class, and all of the remaining ones will be available at the start of the second week of class. So if you know you have a schedule conflict coming up, please work ahead. So why don't we allow late work? Why can't we accept work with a 10% penalty a day late or something like that? Well, every day that we allow late work is a day that we must limit discussion on the graded work or limit the grade release. The net effect ends up being that if we allow you to submit late with a penalty, a large number of students, regardless of how significant the penalty is, will submit late. So it ends up being that we have to push discussion back, and you end up learning less. And so we have decided that we just do not accept late work except for the limited circumstances already mentioned. Academic integrity. Everybody's favorite topic, right? Well, I would rather have this conversation up front and save you from potential heartache later than have you have an academic integrity problem. So the clearest way to summarize our policy is do your own work. If you do this, you will be fine. Now, I think it is also important to discuss what we consider to not be doing your own work. So we would say that discussing a high-level approach to a problem is fine, but sharing your code is never fine. You can use pseudocode to discuss with your classmates how you'd approach a problem, but you have to be careful, even with pseudocode, that you're not sharing the specifics of your implementation. We're going to come back to this one in a minute. And there are some cases where some of our labs have specific answers, like the pattern is X. We expect you to not share that answer. AI is not fine. We used to have a more permissive AI policy, but we had a recurring issue where students would follow the policy. They'd even say things like, "Don't show me code" to ChatGPT, but it would walk them through an algorithm in such granular detail that we had a number of cases where multiple students claimed that they had followed our policy to a letter, but yet they produced work that was almost identical. And so what that tells us is it wasn't actually their work. But in this case, the students thought they were fine, and so we've adapted our policies because we want to save you from that heartache. Now, one of the ways that things have historically gone off the rails is if students are discussing things in too great of detail. And it's easy to have a conversation that's fine that goes to a place where it's no longer fine. And so the best defense we have to make sure that what you're doing isn't going to cause you future problems is that we tell you to keep all discussion about coursework on either the class ed or the class Slack. And this way, if your conversation is starting to get off track, we can nudge you back in the correct direction. Where if you're off of our platforms, we don't know what you're talking about. We can't help you get back to a good place. I think this should go without saying, but it has been a problem in the past, so don't post your classwork online. The only version control system you should be using is the Georgia Tech GitHub, and this is because a number of the common file sharing sites, like GitHub and Dropbox, have at times had permission settings where by default things were much more public than people realized, or if you had a paid account and you stopped paying, things became public. And you are responsible if the contents of any repository that includes your coursework ever become public. This is by Georgia Tech policy, but I think it's easier to just deal with it up front and tell you, please don't put your work in places where it could become public. Now, if you use any third-party sources, so this would be anything beyond the provided course materials, we want you to cite it. Now, you're going to be turning in exclusively source code for places where you could use third-party materials, so the best way to do this is to put a comment in your code and say something like string reverse algorithm based on Stack Overflow and give a link. That way, if there's any question of why there are multiple students who had similar code, it's easy for us to figure out, oh, this is something that is permissible and we had multiple students who happened to pick the same source. Okay, we know that this is nothing to look at here. And if you have any doubts about any of these policies at any time, whether something is allowed or whether something is a violation of our academic integrity policy, please ask, because we can't roll back the clock. So if you ask us before you do something and it's not okay, we can stop you before you have a problem. But if you just assume something is okay, even if you're not sure, and it turns out it's not okay, you are still responsible for that. So if you have any doubts, please ask. And it is important to note that the Office of Student Integrity, by their policies, the minimum grade we can give you, or the minimum penalty we can give you for work found to be an academic integrity violation is a 0 on that work. Collaboration. Collaboration is working with other people cooperatively to enhance understanding. Collaboration is a good thing. We encourage you to share ideas, explain concepts to each other, share resources relating to software analysis or other problems or things in the news that might be relevant to your classmates. Explain your high-level approach to a problem. Again, as we talked about before, no implementation specifics or code, and your pseudocode is generally safe to share as long as it is kept at a sufficiently high level. And we'll walk through an example of what we mean by this later on. The opposite of collaboration is plagiarism. Plagiarism is using someone else's work instead of doing your own work. We expect you to complete labs and our exam by yourself. We expect you never to share your lab code or lab reports. We expect you to never use someone else's code or text in your submitted work. If you have any reason why you think that is okay, it absolutely must be cited. And I would say that AI, even though who the someone is may be a little bit ambiguous, AI for our purposes counts as someone else's code. Attribute any quotes. Never consult project code or text that you find anywhere unless it's specifically permitted in the lab instructions. So you should absolutely not be asking any AI, how do I implement delta debugging in Java? You should not actually be asking it how you implement delta debugging in any language. But if you are asking an AI those kinds of things, that is, for our purposes, the same as asking a classmate, how would I implement this? And it's clearly a problem when you're asking a person, and we see no difference if you're asking an AI. Plagiarism can also include using unauthorized resources on our exam. And just like before, if you have any doubt whether something is allowed or not, ask the course staff. AI policy. Again, this is a change from where we once were. but I think it's a reflection of how advanced many of the AI tools have been and the fact that the course we tried to chart out was proving to not be tenable in many cases, where students tried to follow the policy and did a very good job of following it and still ended up submitting things that really weren't their own work. So because of that, our AI policy is now do not use any AI tools for your coursework. Going along with this, we expect you to never share class materials or your work with an AI system. Your implementation should never become part of the training data for any of the AI systems. And going along with this, do not use AI to explain or debug any graded work. So it is absolutely an academic integrity violation if you take the PDF of our lab assignments and upload it into any AI system, regardless of what you do with the output. And submitting AI-generated work is an honor code violation. Examples. Your classmate is struggling to use a LLVM iterator. They ask you for help. Option 1. You point them to the LLVM documentation for the specific type of iterator they're trying to use. Option 2. You look at their code and help them correct their syntax. Option 3. Without sharing code, you discuss how there are several possible approaches, the pluses and minuses, and they realize a different approach makes more sense for their code. Option 4. You tell them exactly what you did, why, and how to get the values required to implement it. Why don't you answer this now as a quiz, and then we'll talk about what the correct answers are. In this case, I would say that 1 and 3 are collaboration and acceptable, and 2 and 4 are plagiarism and unacceptable. Another example. Your roommate has been working on the fuzzer for 2 weeks and still hasn't crashed one of the provided programs. Option 1. You tell them what pattern you found crashes the program. Option 2. You tell them the mutation strategy that crashes the program. Option 3. You offer suggestions of the kinds of mutation you found effective in general without telling them which ones go with which programs. And option 4, you leave your code up on your computer and they look at it. Now this could be intentional, like, hey, come look at this. It could be unintentional, like you leave it open on your computer sitting on the kitchen table and leave the room. Either one has the same result. So which of these are okay? Well, I think I've made it clear that option 4 is not okay, but only option 3 in this case would be collaboration. The other 3 would be plagiarism and not acceptable. Now, I should also call out that over 25% of the cases I have ever submitted to the Office of Student Integrity are cases where I know that the students have had a personal relationship outside of class. So the alarm bells should have been going off as soon as I said your roommate in this question, that should be, if you have someone who lives under the same roof as you who is also enrolled in class, you should be extra cautious to make sure that you do not unintentionally cause yourself academic difficulty. I've mentioned pseudocode a couple of times, but let's talk about what is appropriate detail in pseudocode and what is overly detailed pseudocode. So what we're going to try and solve here is we're going to try and calculate the value of pi using Monte Carlo methods. This is actually a fascinating thing. If you've never done it before, I'm sure you can find a video on YouTube that explains how to do it. So what we're going to do is we're going to start with some bad pseudocode. So our bad pseudocode says run the simulation 10,000 times, find 2 random variables between 0 and 1, find if inside the circle, radius greater than or equal to 1/2, centered at 1/2, 1/2, and then use the Pythagorean theorem, and we're give the whole theorem there, equals radius, and pi equals 4 times the ratio of the inside of the circle to the total number of tested values. So that's bad pseudocode. That's not code. You can't feed that into a compiler and run it. But if I gave 5 or 10 or 20 or even 50 of you this pseudocode and ask you to implement it in C++, you'd probably write very, very similar code. In fact, here, I did just that with 2 of your TAs, and you can see that inside of the basic framework I gave them in gray, they actually calculated nearly identical. Even though they didn't see each other's code, using this pseudocode, they made almost identical implementations of the program. Now, a good pseudocode would be use random values to inside the square, use the Pythagorean theorem to find the distances, and then your final formula is pi equals 4 times the ratio of points inside the circle divided by total points. Because using that pseudocode, we tried it with TAs. I'm not going to show you the code here, but they came up with quite different implementations, even though the actual steps of the algorithm were pretty similar. So if you keep it high enough level, I could expect several of you to implement it and come up with fairly different results. And if it's too detailed, I'd expect several of you implementing it to come up with almost identical results. One of our expectations for you is asking good questions. So what makes a good question? First of all, include appropriate background. You don't necessarily have to give every detail you've ever learned on the subject, but you should give us enough background that we can understand what you've tried so far. And call out specifically what you have tried, and so we can verify that you have tried appropriate things. And in specific, if your question is, it doesn't work, we can't answer that. I mean, what is it? Okay, even if it is clear, it could not work for a million different reasons. Now, we do encourage you to keep your questions concise. Sometimes students will write us the Encyclopedia Britannica for a fairly basic question, and you don't need to do that, but you should give us enough background that we don't have to ask you follow-up questions just to figure out how we can help you. What are the limitations on the help that we will give you as a student? First of all, we do not pre-grade work. So if you come to us and ask, is my solution correct? Our answer will be, I don't know, or something like that. We frequently will ask you questions, even in these cases, to get you thinking. So please don't be frustrated if we respond to your question with a question, because we're trying to get you thinking the right ways, not feed you answers. We also, unfortunately, cannot teach you prerequisites. So if you have never seen a C family language before, unfortunately, we're not going to be able to teach it to you. We also may have time limits, in particular with office hours, when it's busy. We can't spend the entire hour with you if there's 10 other students in line and just one TA running them. And we're not going to be able to troubleshoot your environment if you're not using the expected environment. Realistically, that means that we expect you to either use the Docker container that we've provided for you or the course virtual machine we've provided for you. Both have been set up to mirror what you will see on Gradescope, and so they should be fairly similar to what you're going to have in the official grading platform. But if you want to try and install LLVM directly on your hardware, I'm not going to stop you, but especially if you have Windows, you're going to be in for a bumpy ride. We're not current because of some of the other tools we use against LLVM. We're not current on the overall version we use. We want to stick with one version for the whole class and not have you switch around between labs. And because of that, it can be quite a bumpy ride to get all of the dependencies to the same versions we have to see the exact same results that we see. So please do yourself a favor and use one of the pre-configured containers. So you need some help. How do you contact us? Or if there's any kind of issue where you want to contact the course staff. Ed is always a good way. You're able to create a private post which only the course staff can see, and private posts are appropriate for grade questions, anything that would be an academic integrity violation if it were public. But if you have a general question, please ask it publicly, because it's not fair for us to answer a question for you when other students would also benefit from having that answer. We also have office hours available via Slack, and that's another great way to get help from us. That's real-time interactive. So if there's office hours at a convenient time for you, that can be one of the best ways to get help from us. But anything that is critically important should be on Ed. Again, we will pin anything that we expect you to read, but we can't have a clarification that might change how the whole class thinks and have it only on Slack. Please do not use Slack direct messages outside of the ones that we initiate during office hours. The Canvas messaging feature, it tends to go to an inbox that doesn't alert us, or even worse, commenting on assignments in Canvas. They make you think that it's going to send us an alert or something like that. It doesn't. The only way we see that you've commented on something is if we happen to be looking at your submission within Canvas and notice that there's a comment there. Email. Other than some very limited circumstances where some kind of institute policy forces us to use email, we prefer to keep everything on Ed. It's just easier for us to make sure that nothing falls through the cracks if it's all in one inbox. Class participation. We can give you some extra credit, up to 5% of your total grade, for good class participation. This is to encourage you to collaborate with your classmates and to help one another. We will give you credit for non-anonymous, non-trivial posts, potentially reading other students' posts, although this is minimal credit compared to making your own posts. This includes both the original poster and follow-up comments. There's no differentiating in our formula. We also give additional credit for particularly insightful posts. As I mentioned before, posts with a high number of hearts. So if you find a post helpful, put a heart on it. It helps out your classmates. We also reserve the right to remove credit for trolling, negativity, academic integrity violations that you're posting, or anything that makes the class a worse experience for your classmates. We will update the score that shows up in the Canvas gradebook for class participation several times during the semester, and I typically start doing that about a week after we release the midterm exam grade. So let's end with some advice from previous students. One student says, I wish I had known that this class is about many different software analysis techniques to find bugs within a program and not really much to do with testing, as most software engineers would think of the term. Some other advice: no basic syntax, particularly in C++. Several students have said something along the lines of, I followed these steps which helped me a lot to get my labs done. First, read the instructions for the lab to get general requirements, but don't start working. Then watch the lecture to fully understand the concepts in the labs. Then watch the lab intro videos. These are extremely helpful. Then read the instructions again, and then finally start working on the lab. We also encourage you to not overthink things and to start labs as soon as possible. A number of the labs in this course will be easier if you have the opportunity to work on them for a while, and then if you hit a roadblock, take a break and come back with fresh eyes and a fresh look at the lab, and oftentimes you'll find it much easier than just trying to power through things. But you won't have that luxury available if you're starting the day before it's due. Other students have suggested making sure that you're reading ed posts, not being afraid to post questions, and taking the practice exam questions. These are the questions that you can find in Canvas, linked from the sidebar as quiz and exam preparation. And these questions also all have videos that show how to correctly work them. I'd encourage you to work them on your own before looking at the videos, though. But this student says, on practice exams, try and work the questions under the same restrictions as real exams. We used to restrict you to only digital scratch paper. That's actually out of date. You can use physical scratch paper now, but it still can be useful to limit yourself to the same resources available while if you're practicing for the exam, where it's not open everything. They encourage you to create an exam note sheet. Figuring out what you want on the exam note sheet is actually more helpful than having the note sheet on the exam, but we find that students who make a note sheet generally do better than those who don't, and a huge number of students who make note sheets end up not actually looking at them during the exam, that by figuring out what your weaknesses are and writing them down, oftentimes they're no longer your weaknesses. And taking the quizzes that are inline in the lessons, if you're watching them in ed, can be helpful as making sure that your understanding of the material is correct. GDB can also be a useful skill, although GDB or a similar debugger is by no means required, and that's not something that the course staff officially supports, but many classes have had students who have been very helpful. I use GDB all day kind of help. Let me help you figure out how to set it up for this lab. Our expectations for you are to try things on your own, experiment before asking questions, search for existing answers, in particular on ed, before asking, read the instructions, documentation, ed, submission instructions, and if you do all of these things, you will have a successful time in the course. You can also help us improve by taking the KPI survey every week in Canvas. It's 5 questions on a 5-point Likert scale, and it helps us understand if there's any areas in the class where the materials are unclear or it needs other kinds of improvements. Now, what can you expect from us? We will answer your questions in under 48 hours. We'll get you your grades back within 2 weeks, typically much faster, and you'll know how you're doing in class at all times. Now, what should you do this week to get things started? Read the syllabus, take the syllabus quiz, do the intro survey, watch lessons 1 and 1.5, and get started on Lab 0. It'll be due on the second Monday of class. We also encourage you to introduce yourself on ed to your classmates, review the course schedule, and as I've mentioned a couple of times, all the labs will be available starting the second Monday of class. That is the start of the second full week of class. So we hope you all have a great semester and that we now have a common set of understandings of what we expect. See you on ed.